rectangular box is constructed from a 10 by 16 inch piece of cardboard. So it's probably good to draw a picture here. It's saying that's 10, not to scale, 16. By cutting squares of equal length from the corners. So it's like saying there's an X, 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 and so on. You actually saw this problem in your pre-calculus college algebra class before that. Find the dimension of the box of the largest volume. So it's good to say things like I'm trying to max, because you're either maximizing or minimizing, and then what it is. In this case, it's volume.
Okay.
So maybe it's not easy to see here, but the box looks like this when it's folded up.
Yeah.
Like it actually is a box.
Right, like a 3D box.
Yes. Okay, and so this is X, is the height. Height is X. The length is not, or width, whatever you want to call it, is not 16. It's not 10 anymore. It's 16 minus 2x, because you're cutting out from both. And then this is 10 minus 2x, because you're cutting x from both.
Okay.
Is that okay? Is that clear? Okay. So now volume is equal to length times width times height. It's x times 16 minus 2x times 10 minus 2x. And that's it. So in pre-calculus, and I don't even know if I said this to you, in pre-calculus, you would graph this. It looks something like this. And you find that spot right there. But because you're in calculus, you can take a derivative, set it equal to 0, and that's what you're expected to do here.
Okay.
Before you take a derivative, though, you want to multiply. It's a lot easier to take a derivative of using power rule. This is product rule twice. With chain rule, it's really bad.
So foil it out.
Yeah, so we're going to FOIL this and then multiply everything by x.
Okay, so 160.
Yep.
First outside, yeah.
Okay, and then you got this x here. So
160x. Oh.
Yeah, I'm gonna combine some things. But yeah, you got the 160x down here at the end, minus 52x squared plus 160x.
Okay.
Let's just check here. Okay. X cubed. Okay, looks good. So now you take a derivative. So v prime, power rule here, 12x squared minus 52x plus 160.
So isn't it 52 times 2?
Yes, it's 104x. Thank you. And then maybe this factors. This is yeah, this is where you can spend a lot of time like on prerequisite stuff. I'm going to go right to an online calculator here and see if we can get the answer quicker.
Right.
But you should be prepared to have to do this on your own. This one does, in fact, factor to x minus 2, 3x minus 20.
Okay.
Okay. So you set this equal to 0. You always set the derivative equal to 0, and you're looking for the critical points. The critical points are when x minus 2 equals 0 and when 3x minus 20 equals 0. So either when x equals 2 or when x equals 20 over 3.
Okay.
Okay. Now back on the graph. Well, I probably shouldn't jump to that. So the next thing is you create a sign chart for this. And what's the smallest value that x can take on in the context of this problem? Is it even reasonable to take a cut of 0?
No.
No. And so it's really parentheses here. And then on the other side, like you can't cut too much. If you cut more than 5, there is no box, which is half of 10. You can't cut more than 8 because that's half of 16. So it ends over here at 5. So this is actually over here at 5. So this critical point on the right, this is approximately 6 2/3. It's too large. So you actually exclude that one.
You exclude
This,
6.
this other one over here, this 20/3.
Oh, okay.
And let me go back to the graph and explain why again. So the graph actually looks like this. That's 2, and that's the 20/3. Like, do you agree it's a critical point?
Right. Yeah.
It's just it's outside of the
domain.
domain.
Okay.
Okay. So you put your 2 here, and you test points. I think we were doing this last time. You test like maybe 1, this is 0. You test maybe 3. You're looking to see whether this line right here is positive or negative. So when you test 1, positive, 1 minus 2 is negative, 3 minus 20 is negative. So you have positive, negative, negative. That makes a positive.
Okay.
When you test 3, positive, 4, 3 minus 2 is positive. This one's negative though. So positive, positive, negative gives you negative. So again, the curve goes up and it comes down. So 2 must be a max. And I already kind of convinced you of that over here, because that's what this thing looks like.
So what are they asking you to find exactly in the problem?
So that's why you write it out here, the max volume. So the volume is this formula here, but you need X. And we know that X is 2.
So then you plug it in.
Yes. Okay.
Okay.
So V equals 2 times 16 minus 2 times 2 times 10 minus 2 times 2. 2 times 12 times 6. Now your instructor is probably going to expect like proper units in this one, and maybe even a sentence.
Okay.
So just the right units basically. So this is 144 inches cubed.
His volume is always cubed. Okay.
Yes. All right. How was that for you in terms of like?
That was okay.
Do you
That
think you
makes
could
a
do that
lot.
on your own?
Yeah, I was struggling with the Math Excel ones.
Yeah. That's the only optimization problem they give you. The next ones are your AP exam review. So I would suggest either doing the AP exam review questions 70, 71 next, or going back to the beginning. What would you like to do?
Let's do 71.
Okay. 70 or 71? Because we have to do them both, if you're okay with that.
Yeah, whatever, either.
Okay. All right.
Whatever.
All right. So the 70 has a graph. Okay, so this is all related to this graph here. And let's look at the first question. It says, for what value of f let me switch the order of these. It's easier to do that this way. Okay. Okay. For what value of x in the open interval -3 to 3 does f have a relative maximum? Justify your answer. So the first thing is, are you given f or f prime in this picture?
The derivative, so f prime.
You're so you're given the original, and
But isn't the accompanying figure shows the graph of the derivative?
Oh, I'm so sorry. You are totally right. Derivative. Yes, this is f prime. Wow. Okay. I was surprised, but and that's why it's important to know, because if it is f, it's one set of rules, and if it's f prime, it's all the ones we've been studying. So to determine where it has a relative maximum, you want to make a sign chart. Best to make a sign chart here from -3 to 3. And you're looking for like crossings, like see how it crosses at -2, it crosses at 0, -2, 0, and then at 2 again.
Yeah.
Okay. So now we look at, because we're looking at the derivative, we look at whether it's positive or negative. So see how in this region here from -3 to -2, it's positive because it's above the x-axis. Then down here, it's negative because it's below the x-axis. And then up here, it's positive again.
Positive and positive.
And positive. So a relative max occurs when you go from positive to negative. So the max must be here at -2.
Okay.
Because it goes from positive to negative. And that the reason I like the sign chart is it takes out like the I don't know, the bias maybe of seeing the curve. Like you just look at sign changes. You don't care whether the graph's going up or down or left or right. You don't care about any of that.
Okay.
Is that okay?
Yeah.
Okay. Now part B we can actually do from the information we just did in part A. Part B says, where does it have a relative minimum? So minimum occurs when you go from minus to plus.
So 0?
It's 0, yes.
Okay.
And then what is going on here at 2, since it's plus to plus, just as an aside here? Is anything happening there?
Is it a tangent?
It is. It looks like this. The original graph looks like that at 2. It is a horizontal tangent, but it's increasing and then it's increasing some more.
So nothing.
But nothing's happening.
Yeah.
Okay. Part C. For what value of x is the graph of f concave up? So let me grab the graph one more time. Oops, grab that one more time. Okay, so when you're looking at the derivative, concave up, this applies to the derivative. It's concave up when f prime is increasing.
Mm-hmm.
And that means it's going up and to the right. So where is this graph over here going up and to the right?
-1 to 1.
-1 to 1, and then
2 to infinity.
Just 3, because it's
Oh,
it considers an open interval. So we would say from -1 to 1 and or comma. I don't know however you're
do a union.
It's not completely correct because union is for comma is the correct. But
Okay.
the union is like for domains.
Okay.
Although I mean, okay. So then where is it? I know it doesn't. Let me make sure it doesn't ask. I was gonna say, where is it concave down? Separate question.
-3 to -1.
That's
and
right.
Then 1 to 2.
That's right. Great. Okay. Suppose. Oh, how much curve sketching do you think you'll do on this test?
Probably none. Not
Okay.
a lot.
All right. This is really hard to do, and it's not if it's not done. If you're not doing it, we don't want to spend much time on it. But I'll draw one here for you.
Yeah.
So if it tells you that f of -3 is 0, that means that over here, like this is y and this is x and this is actually the f. They're telling you that it starts here at 0. Okay, and we know from our previous analysis that there is a max at -2 and a min at 0. We already have that in there. Okay, so but they're giving this is like your starting point. Start here. So we're starting there. Okay, so from -3 to -2, the graph is increasing because it's above. This is above the x-axis. This is the derivative again. Since the derivative is above the x-axis, it's increasing. So I'm going to increase. There's my increase. From -2 to 0, it is decreasing.
Okay.
And so actually, let me change this slightly. So I'll make it go like this. Okay. So at 0, it's decreasing at 0. And then from 0 to 2, it's increasing again, but then it increases some more. So at 2, so it's increasing. And then it's increasing some more. I didn't get that quite right. It's increasing some more like that. That's one possible graph of this. So see, it has a max at -2. There's a min at x equals 0. And the rest of the features.
Okay. Yeah, I don't think we're going to be doing much of that.
Okay. All right, so 71 is not optimization, sometimes confused with optimization. It's a related rate question. I think we did some of these at some point. Okay. The volume of a cone, which is given, will your instructor give you these formulas or do you have to memorize them?
He'll probably, I can ask him that.
Okay, that's a good one to find out because it could be just a little extra thing. The volume of a cone is increasing at the rate of 4 pi cubic inches per second. So the units tell you what this is. This right here is V prime. V prime, because it's cubic inches, that's V. And then the per unit time is generally the rate. So V prime is 4 pi. And you want to kind of grab these quantities as you read it. So at the instant when the radius of the cone is 2 inches, so because there's not inches per unit time, that's just a value, r equals 2. Its volume is 8 pi, so V equals 8 pi. And the radius is increasing, so that's r prime. And it's because it's inch per unit second is 1/3. R prime is 1/3. So you want to try and grab as many of these quantities as you can before you do the problem.
Okay.
And now I'm going to give you part A, because this could be overwhelming if you had to do A, B, and C without kind of knowing this stuff first.
Yeah.
At the instant when the radius of the cone is 2 inches, that's the same thing as here. What is the rate of change of the area of its base? So notice it's not even talking about the volume anymore. What's the base of a cone? It's a circle. Party hat, right?
I thought you meant like the formula.
Yeah, the cups they give you at the golf course. Yeah, so the area of a circle is pi r squared.
Yes.
Okay. So this one is asking it. I mean, you maybe got extra information in here. It's asking for the rate of change of the area. They want A prime.
Okay.
So when you take a derivative, when you're in this kind of related rate world, because r is the variable, the implicit derivative is taken. So it's 2 pi r, that's power rule.
Yep.
But then r prime.
Oh. So R is like a Y.
Yes. Well, but any variable, like there's an H, it's a variable. X is a variable. So X is treated like Y, where it's X prime. Y. There's always a prime to go along with it.
Okay.
All right. So then, what are we again? Like gotta go back. What are we trying to find? We're trying to find the rate of change of the area of its space. We're trying to find A prime. So do we know any of these quantities? Do we know R? Yes, it's 2. R is 2. Do we know R prime? Yes, it's 1/3. So you just put the values in.
And then so it's 4 pi times 1/3. Oh yeah.
So 4 pi over 3, but the units are really important here. What are the units of area?
Squared.
Inches squared, but it's always per unit time. So we got to go back and figure out what it is. It's per second. Yes, per second.
Okay.
Per second. Is that okay?
Yes.
Okay, part B is something completely different. It's totally dealing with something else. These are separate problems. At the instant when the radius of the cone is 2 inches, what is the rate of change of its height, h? Okay, so the only thing that has h in it, oh, I did that bad. The only thing that h in it is the volume, 1/3 pi r squared h.
Okay.
So the thing that's frustrating here or hard here is that only thing you're actually taking a derivative of is this on the right, this r squared times h. This 1/3 pi just comes along with it, but the r squared h is a product rule. So this is a product rule derivative.
So it's R. r squared times h prime
Okay,
plus
good. Plus
h times 2r.
R prime.
2r r prime, yeah.
Yes, like that. And that's it. It's hard, you know, it's easy to leave one of those out, but it's really, really critical. Okay. So what are we solving for here? Like, what are we trying to find? We're trying to find the rate of change of its height h. We want h prime. So there's h prime right there. So hopefully everything else is given. Are we given v prime? Yes. If you go back up, v prime is the 4 pi. Sorry if that was too fast to see, but hopefully you got it
Yeah.
there. Okay, and then what is r? R is 2. H prime is the thing we're solving for. H, do we know H? Did we get H? No, so we don't have H, but we will find it shortly. R is 2 again, and R prime is 1/3.
Okay.
So there's one, the possibility here, if they don't give you a variable, that means either it's the thing you're solving for, which is not the case here, or you have to use another equation to solve it. So the other equation you're going to solve for is actually this one that you were given. Volume. Okay,
Isn't
sorry.
that what we're solving for though? Because it says what is the rate of change of its height? So
We
r
want H.
squared.
We want H prime,
Oh, okay.
not H. Yeah. So volume is 1/3 pi r squared h. So it tells you its volume. It tells you its volume is 8 pi. And it tells you the radius is 2. And so the only variable you have left is h. So oftentimes, if they don't give you the quantity, you have to go back in and solve for it. Like, do you remember doing like some of the ladder problems or a triangle problem where
Yeah.
you have to solve for one of the variables, not the derivative?
Yeah.
Yeah. So this is, you know, prerequisite skill. This is something you're supposed to be able to do relatively quickly. On the right here, let's simplify this out a little bit. It's 4/3 pi times h. Okay, so the pi's cancel because they divide out, and then you multiply both sides by 3/4. Okay, and then on the left here, it's 6 equals h, and that's the value that goes back into this line up here above. So there's a lot going on. So let me just rewrite here. So 4 pi equals 1/3 pi. This is 4h prime plus h is 6. 6 times 2 is our 4. 6 times, what did I say? 6 times 4 is 24. A third of that is 8. Okay. And then probably want to clear out this, like, see how the pi's cancel now? They go away. You can multiply both sides by 3. So you have 12 equals 4h prime plus 8. Subtract 8 from both sides. 4 equals 4h prime. H prime equals 1.
Okay.
But what we want are the units, the correct units, the height, the units of height are inches per second. Whenever it's a derivative, it's always going to have a time unit associated with it.
So length, width, and height are just inches, like no squared or anything like that.
That's right. Yep.
Okay.
Is that okay?
Yeah.
All right. Part C.
It's just like a lot to get to one thing.
It is.
You know?
It is. I mean, you're only gonna get 1 or 2 of these on your exam because they're,
Right.
you know, maybe one related rate, one optimization. Just only so much you can do. Part C. At the instant when the radius of the cone is 2 inches, what is the instantaneous rate of change of the area of its base with respect to its height? Okay, so the area is pi r squared, and they want a prime, but they want it in terms of h. So you have to go to your volume formula, and you want to solve for r squared. You want to solve this formula for r squared because you're going to plug it back in here.
Okay.
So of r squared is 3v, okay, over pi, and then there's an h there. So this, and this is one of those like sort of advanced techniques where you solve for the square of the variable, or you solve for something other than just the variable itself. The area is pi times 3v over pi times h. And these pi's cancel. So your area is 3v over h, or 3 times v over h. So to find a prime, you have to use a quotient rule on this part.
Okay.
So it's 3 times bottom times derivative of the top minus the top times derivative of the bottom over the bottom
H
squared. Yeah. All right, so you actually have all these values. H is 8 because we're 6. I'm sorry, it's 6. We found that already. We don't want to redo stuff we already found. V prime is 4 pi. That's given.
I did that, yeah.
The volume is 8 pi. H prime is 1. We just calculated that in the previous problem.
6
squared. Yeah. So it looks bad, but 24 pi minus 8 pi is 16 pi.
Over
So
36.
yeah, so it's 3 times 16 pi over 36. Lots of things cancel here. That makes 12. 4 goes into both, so that's 4 and 3. So it ends up being 4 pi over 3. But what are the units of area? It's inches squared per second. Got to put the units down. They'll mark you on the AP for sure on that.
Okay.
Okay, so that those are the longer problems. I mean, those are going to take you a while to do. I'm not saying these other ones are short, but for sure, for sure, you better have these down so you can do them quickly. Should we just go back to 3, and actually we did 3 in a previous lesson, I think.
Oh, we did?
Maybe, I don't know.
Yeah, let's just start from the beginning now, I guess.
Okay, great. Okay, so 3 and 4. Okay, so 3. This one actually is quite long.
Oh no. Yeah. So sorry, it's kind of blurry. I just took it with my phone camera.
Well, you got to get that iPhone 13 so you can take video. And
I know.
skip college and just do video. All right. All right. So in this exercise, we're trying to figure out first where it's increasing and then decreasing. So these first two come from the first derivative.
Okay. And then second derivative is concave.
Yes. Okay. So the derivative is you gotta be really solid on these. You got to know that this is product rule. But within this one right here, there's a chain rule also.
Oh,
okay. So let's do that together. So
x squared,
and then derivative of this, you keep it. Okay, but then the derivative of the inside function, remember 1 over x squared is x to the minus 2. So its derivative is
negative 2x.
Yep, to the minus 3 power. And we're going to write it this way though, because it'll be easier for canceling. Negative 2 over x cubed. Plus
e to the 1 over x squared times 2x, yeah.
2x, yeah. All right. So from here, like once you have the derivative, there's no more calculus. This is just about your ability to manipulate the equation and see what you factor out or not. We're going to do a little simplifying here. Y prime, this x squared cancels with all of those. So you have minus 2 over x e to the 1 over x squared plus 2x e to the 1 over x squared.
Okay.
All right. So now you want to factor out what is common to both. And without getting too complicated, let's just factor out the 1 over x squared, e to the 1 over x squared. So you have minus 2 over x plus 2x, like that. And you're setting this all equal to 0, by the way. That's the whole point of this.
All right.
So this first part is never equals 0. E never equals 0 as it stands. So you're just looking at the inside one and you're figuring out, well, where does that equal 0? So you set it equal to 0. Minus 2 over x plus 2x equals 0. And you solve for x. So I'll move this to the other side. 2x equals 2 over x. Cross multiplier, butterfly thing. 2x squared equals 2. X squared equals 1. So x equals plus or minus 1. Those are your critical points.
All right.
So when you make your sign chart here, or y prime, because that's what we're doing here, you're going from minus infinity to infinity. There's 1, I'm sorry, there's -1 and there's 1, but you have to go back and you have to know what the domain of this thing is. Because if there's any restrictions, which there are, x cannot equal 0, because you can't divide by 0.
Oh,
You have to include those on your sign chart here. So while this is not a critical point, that's where maybe you got to label them.
so by like the domain, you just mean like if there's any restrictions or?
Yes. And
Okay.
like this starts at minus infinity and goes to positive infinity, but you have to include exception points.
Okay.
And that's why this is a really good question, but it's because what ends up happening is your sign chart here will look different based on whether you include this point or not, this 0. Like if you aren't paying attention to that.
Right.
So you gotta test 1, 2, 3, 4 regions, and you're testing them in this factored line here. So I'm actually going to bring this back down, because it's like you can get so far away that you don't know where it is. So you're testing it in here. Okay, and I'll just make a point that this E is always positive. This is always positive. So it really comes down to like what's going on in here. So let's test a number over here, like 10. So this is always positive. Minus 2 over 10 is whatever it is, but it's plus 20. So that's positive in there. So do you see how that's positive? Because this is always positive. 20 is much bigger than that.
Yeah.
Okay. And then this is where it gets a little harder. So we got to test like 1/2, right? The E is always positive, so you don't have to worry about that. Minus 2 over 1/2 is -4. Plus 1 is -3. It is negative. Negative times a positive is negative.
Okay.
So now let's try -1/2. That same thing here. This makes this positive for this time. -1. So this is positive.
Okay.
And let's try -10.
So negative, not negative.
This
right.
is some positive small decimal plus -20. So this whole thing inside your parentheses is negative times a positive is a negative.
Right.
So notice if you didn't like realize that this 0 is important here, you could have gotten anything in here. You could have gotten minus to a plus or minus to a minus, depending on what you tried. Maybe you would have tried 0, notice something weird was happening. But in terms of like where it's increasing and decreasing, which is, by the way, that's the original thing we're asking about, increasing and decreasing. If you don't have this 0, you miss that window also. So it's decreasing. Maybe we can summarize this. It's decreasing from minus infinity to -1, comma, 0, 1. And then it's increasing. It's increasing from -1 to 0 and 1 to infinity.
Okay. And then for the concave up, concave down, you do the second
Yes.
derivative and you just do the same thing though, right?
Yes. Could we hold off on doing that either until next time?
Yeah.
Or whatever. It's not pretty. And you got other stuff here you want us to look at. So 13. Oh, okay. I've got to do the same thing on 13.
13 is not a good one. We can skip
Well,
it.
it's kind of the same deal. Let me cover. Let's look at 17, because 17 is what we're doing. I think we've got a session tomorrow too, so we can always come back and do more. But let's cover broadly everything today. Didn't snip in right. Okay, so we're looking at 17 next, and part B over here is local min also. Okay, it says you got to figure out where a local max, where a local min is occurring. But notice they're giving you the derivative. So this is kind of like the graphing questions, except they're giving you a function instead of a graph. And do you remember what we did in the graph problem way up here? Remember how we made a sign chart right away?
Yeah.
And you want to do that too. You want to do it where it equals 0. So because the graph hits, you can just detect that. But down here, you've got a function. So you need to figure out where does this 6 times x plus 1 times x minus 2 squared, where does that equal 0? It equals 0 at -1 and 2. So that's what's going to go on your sign chart. -1 and 2. And you're going to test in these windows. And you're testing them back in here. So will you figure out the signs for each of these for me?
Okay, so try to do this in my head. -1 plus 1 is 0.
You can't test this point here. You have to test something in between.
Oh, right. Okay, so you test like -2, right?
-2 is great.
Okay, so -2 plus 1 is -1 times 6 is -6. 2 minus 2 is -4. I need to write this down. -6 times -4. So that one is negative. Then the -2 is negative, right?
The -2. So this one's always positive. So it comes down, and see how the 6 is always positive. So it comes down to just whatever this is.
So
yes,
negative.
it's negative. Yes.
And then 0 is positive. And then 3 is also positive.
Yes. Okay. So what is happening when you go from minus to a plus?
It's minus to a plus. It's a min.
Yeah, if you can see, I'm trying to trace it out here. Yeah, this is a min, and plus to plus is
Nothing, a vertical
nothing.
tangent.
Yeah.
A horizontal tangent, right?
Right. Yeah, and same with minus to minus. It's a horizontal tangent, but it's nothing. It's not.
Yeah.
So you can say, here's what all you can say right now is you can say there's a min at x equals -1. There is no max. Okay. So part A, if we're doing this, there's none. Part B is there's a min at x equals -1. Is that okay?
Yeah.
Okay. Part C, and this is why I want to do this problem. We have to find the point of inflection. So we got to take the derivative of the derivative, right? You've got to be able to take the derivative of this thing up here, this horrible mess here. So it's a product rule. Will you give it a try before I jump in and show you how to do it? If you need help at all.
What do you do with the 6 in front though?
I see. So there's a couple options here. Let me snip it down. Couple options here. One is to just leave the 6 on the outside the whole time, or to treat like this as U and this as V. That's one option. I mean, whatever you want. I mean, 6 on the outside is fine. Go ahead.
Can you deal with the Yeah, so can you just leave the 6 and then you like multiply it out at the end?
Yes.
Okay. So
So are you gonna leave it outside the whole on the?
I think so, yeah.
Okay, so all right, so I'll follow you there. So take a minute or two and see if you can find the derivative of the derivative, the second derivative.
All right. Okay, I'm kind of confused.
All right, so let's do the product rule here together. So it's keep the first, right? X plus 1.
Yeah, I got
The
that.
derivative of this on the right is 2 times x minus 2 to the power of 1.
Yep.
What is the derivative of the inside function? Just 1.
Right.
You don't even need it. Plus
X minus 2 squared.
x minus 2 squared.
And
And then what's the derivative of x
1.
plus 1?
Just 1, right? Yeah.
Plus 1. Okay.
Okay, so I got that far.
Okay. So now, like, we could clean this. Probably first time through, it's good to see this cleaned up a little bit. So it's 2x plus 1, x minus 2 plus x minus 2 squared. So what is common? What is common to both terms here?
X minus 2.
Yeah, so we're going to pull that out. Get x minus 2, 2 times x plus 1 plus x minus 2. Okay, so
Okay.
inside parentheses here is it's 2x plus 2 plus x minus 2, which becomes 3x by itself. And then this 6 and this x minus 2 come out. This is all your second derivative. This is times, by the way. So now we're setting this equal to 0.
So do you set like each part of it equal to 0?
Yeah, you set x minus 2 equal to 0. You set 3x equal to 0. Anything with an x. So x could be 2 or 0.
Okay.
Draw your number line. This is for your second derivative. And you got 0 and 2. Okay, and your test points can be anything in between. You're testing them back in the factored form. So like maybe we test -1, test 1, and then test 3.
Okay, so you can test it in the 6x minus 2 times 3x1, right?
Yes, yes.
All right, so -1. So that's -1 minus 2, that's a negative. Times a negative. So negative.
Here.
Yeah.
So this one's negative and this one's negative. Like I get positive.
That's positive, yeah.
Yeah.
1 minus 2 is a negative times positive, so negative. And then 3 minus 2, yeah, positive.
Okay, so we're looking for, if we got to remember what we're doing, point of inflection. So the point of inflection
is it where it
point,
changes?
Yeah, it's plus to minus or minus to plus.
So there's 2.
Yep.
So 0 and 2.
Yep. So x equals 0, x equals 2.
Okay.
All right. So we're going to quickly move to 23. Right. So there's kind of 2 parts to 23. The first is this going backwards problem. It's they're giving you the derivative. This is the derivative, and they're saying like, you need to figure out like, what do you take the derivative of to get sine? And then what do you take the derivative of to get cosine? So I can tell you the answer, but like, can you remember the derivative? What do you start with to get cosine, or what do you start with to get sine?
Well, first, so like the derivative of sine?
No, like it's always that, it's like it's the backwards. Like the forwards is, if I tell you what is the derivative of sine, it's
Oh,
cosine,
yeah.
right? So to get sine, I'm
You
sorry.
start with the cosine?
Well, that's not true either. to get cosine, you started with sine.
Right.
So I'm asking, what do you start with? So you might say, okay, well, cosine x gives me,
Negative cosine.
yeah, because negative cosine gives you positive. So this is negative cosine x. So I'm trying to, and this is really awkward and weird the
It's
first
just
time.
going like backwards.
Yes, yes. Okay. And so now they're like, oh, it also has to go through this point. You're like, what do you mean it has to go through? So let's try to explain what that means. So this is x, and this is y, or f of x, right? P of x, whatever. So 3 is over here, equals minus cosine pi plus sine pi.
Okay.
So what is cosine pi? So that's your unit circle. It's over here.
-1.
Right. So 3, -1. Sine of pi is 0.
0.
Is this true as is? Does 3 equal 1 plus 0?
No.
So what do you have to add here to make it true?
2.
So plus 2, plus 2, plus 2, plus 2, and now it works.
Yeah.
And this is your answer.
Oh, so they just want you to find like the equation that makes it true, basically.
Yes.
Oh.
This is calculus 2. You'll see this also at the end of, kind of at the end of your class year. But it's like a preview of it.
Oh, okay.
All right. Well, this takes us to the end of our lesson for today. I'll send you the notes out right away, and I guess we'll see you tomorrow. So just have those. If you want us to keep going through this, you can. I would recommend trying to do some of it on your own. And
Okay.
thanks so much for scheduling, and
Thank
see you
you.
next time. You're welcome.
Bye.
Bye now.